Talking about is reasoning. All right, now for us there are two types of reasoning, and generally speaking as well. So we're going to explore those two. They have deductive reasoning and inductive reasoning. We're going to explore the difference between them. So first I've just got some definitions for us. So you might have heard that word premise before. A premise. This is just a declarative statement. Okay, so if it's declarative, that means it has truth value. Either it's true or false. All right, the sky is blue. That's a declarative statement. It's either true or false. All right, the carpet is brown. So any statement that's either true or false, and it's a piece of an argument. Our conclusion is just the result of some reasoning process. All right, so if you've got a maths problem, what you're doing is you're going premise 1, premise 2, premise 3, and then you've got your answer, which is your conclusion, because you're performing a reasoning process. And then an argument is that reasoning process. It's a series of premises that lead up to a conclusion. So let's look at deductive reasoning first. So I've got deductive reasoning is the process of starting with a universal principle and then reasoning to a specific case. So we start with a universal principle and we reason to a specific case. So here I've got some just examples I've made up. All cats have 9 lives. All right, so one way we can think about that is with Venn diagrams, okay? Things with 9 lives. And all cats are things with 9 lives. All right, all cats belong to that circle. Maybe some other things, I don't know. Maybe some humans have 9 lives, whatever. And then the second premise is Garfield is a cat. Okay, so within this circle of all cats, Garfield is in this circle. And so therefore our conclusion is, this reasoning process is, Garfield belongs to the set of things with 9 lives. Garfield has 9 lives. Okay, so we started with one premise. All cats have 9 lives. Garfield is a cat. And then our conclusion, Garfield has 9 lives. All right, no snakes have legs. All right, so if I do some circles again. So things with legs. All right, there's things with legs. And the second premise is that no snakes, the first premise is no snakes have legs. So snakes are out here. Snakes do not belong to this set. Harry is a snake, so Harry belongs to this set. Therefore, Harry does not belong to this set. Harry does not have legs, okay? So we're going, this is true, what's the conclusion? All organisms need water to survive. Butterflies are organisms, therefore butterflies need water to survive. Some teenagers smoke cigarettes. All people who smoke cigarettes waste money, therefore some teenagers waste money. So let's have a look at it mathematically, because that was deductive reasoning. And we've been doing, the unit we're performing is deductive geometry. So this is an example, isn't it? Okay? We've got this line here. A, B, C, D, a straight line, and it's been intersected by BD. Premise 1, angles on a line add up to 180 degrees. That is true by definition. That's our definition. And then we're told, premise 2, angle BDC is 50 degrees, and therefore our conclusion is angle ABD is 130, because angles on a line add up to 180. This is true, therefore this is the conclusion. Okay, so that's deductive reasoning. Let's compare that with inductive reasoning. So inductive reasoning is the process of making many specific observations and then reasoning to a general principle. Okay, so look at the contrast there. Deductive, we go from a general principle to a specific. Inductive, we go from many specifics to a general principle. All right, so I've got here, I dropped the bowl, it fell to the ground. I dropped a bottle, it fell to the ground. I dropped a calculator, it fell to the ground. Therefore, if I drop an object, it will fall to the ground. Okay, so this is the whole enterprise of science. It relies completely on inductive reasoning. Every whale I have ever seen lives in water, therefore all whales live in water. Right, so I saw a whale yesterday, saw a whale today, saw a whale 4 years ago. They were all in the water. Therefore, from all of those specific observations, the general principle is all whales live in water. All right, Bob likes beer, Ben likes beer, Byron likes beer. Therefore, people who start with B, whose name starts with B, like beer. Or you might even be able to reason, people who start with B like drinks that start with B. All right, or something like that. Every person I met in France was rude. So the person at the bank, the person at the cafe, the person at the post office was rude. Therefore, so we've got 1, 2, 3 specific observations. The general principle, every person in France is rude. Now we did this, okay, mathematically, because I said right at the start when we were talking about angles in parallel lines, I said we can prove it deductively, but I said we're going to prove it inductively. I said look at these specific circumstances. All right, I drew 3 sets of parallel lines, and I said look at the first case, corresponding angles are equal. In the first circumstance, both angles, corresponding angles in parallel lines are 52 degrees. Look in the second circumstance, both angles, corresponding angles are 75, and in the third, both are 121. And so we've got 3 specific, okay, individual observations, and then they're coming up to our general principle. Therefore, all instances of corresponding angles in parallel lines are equal. Okay, so hopefully we're starting to see the difference a bit between the reasoning. So, inductive reasoning from many specific observations. This is what you've got to look out for. Are there lots of specific individual observations that lead up to an all statement, some general principle? Or have we started with some general principle and then reasoned to a specific case? All right, so look at this. We have a general principle. Angles on a line add to 180 degrees. Doesn't matter how long the line is. All right? It's a straight line. Angles on a line are 180 degrees. And then we've got this specific case where it's intersecting at 50 degrees. We could have another specific case where it intersects at 70 degrees. So then let's quickly talk about some limits of reasoning, because this is the beauty of deductive geometry. And you saw me getting so excited about like this whole system that we were able to build up that is just evidently true, that we can do through proofs. Premise 1 is true, therefore premise 2 is true. Therefore this whole set of deductive geometry that we've built up is inevitably true. Alright, so that's deductive reasoning. If the premises are true, then the conclusion is necessarily true. It has to be true. And that's the beauty of maths, you know, it's like all you have to do is get the right answer. There's no debate about it. It's not open to subjective interpretation. But with inductive reasoning, all right, even if you have a million observations, okay, it could be the millionth and one observation that contradicts the general principle. Now, every observation adds probability, adds weight to the general principle, but it's never ever proven. And that's why we say stuff like, you know, nothing in science is ever proven, because it's always subject to more evidence coming in that contradicts it. All right, because science as a process relies on inductive reasoning. That's why maths is better, because maths is deductive. Okay, so what I'm going to do, I'll hand out this sheet, and maybe we can work through it together, or maybe I'll give you guys an opportunity to just have a think about it. So on here there's 10 arguments, and you just need to work out whether they're deductive or inductive, just by looking at